So we've probably all heard this before. Correlation is not causation, but it can't go without saying when we're talking about correlation. So often we want to believe that this is true, but we always have to remind ourselves that it's not true. Okay, so why are we so tempted to believe that correlation reflects causation? So this shows a graph that I took from a paper looking at the relationship between physical activity and glucose control in type 2 diabetes. And so you can see here, this is a lovely, strong correlation of 0.75. Okay, so that's, as we saw in the other video, that's a really high correlation showing between physical activity. So here's mean kcals expended during the exercise sessions, and then the change in insulin sensitivity. So we see a positive correlation, strong positive correlation. So the more calories, the more physical activity someone does, the more higher the insulin sensitivity. Okay, and so we think that there's a causal relationship. In fact, there's lots of studies that have shown it, including the study that is shown in this picture here. Physical activity does increase insulin sensitivity. And so whenever you have a causal relationship, you are likely to see a correlation, okay? And so there is a relationship between correlation and causation, namely, if one variable causes another, they are likely to be correlated. Maybe they will always be correlated, okay? But the reverse is not the case. So if two variables are correlated, that does not mean that they're causally related. So for example, here's another graph that was shown in another earlier video as well. This is a boring relationship that we talk about all the time between weight and height, right? And so it's not the case, well, here it may be also the case that height causes weight, but it might be more correct to say that there's an independent factor that causes increased height and increased weight. So for example, age, right? As you get older, up to a point, you increase in height and then you increase in weight. So growth overall. So these are not causally related, but they're likely linked by a common causal factor. So there's some third factor that is causing the increase in weight and the increase in height. So because this factor is common to both, these two look like they're related, perhaps causally, but really there's another causal factor. So that's one way that you could see a strong correlation that does not reflect causality. So here's an article that was published in New England Journal of Medicine in 2012, and looking at the relationship between chocolate consumption, cognitive function, and Nobel laureates. So the author of this paper argues, based on these data, that there's a causal relationship between consumption of chocolate and cognitive function, based on this very high 0.79 correlation between chocolate consumption, per capita chocolate consumption in a country, and the Nobel laureates, the number of Nobel laureates in that country. So you can see here that there's a very strong correlation there. So countries in which lots of chocolate is eaten, like Germany and Switzerland, I guess the United States doesn't eat much chocolate, relatively speaking, also tend to have more Nobel laureates. And so this author is arguing that because of the beneficial physiological effects of chocolate, this results in better cognitive capacity among people in the country, and then thereby resulting in more Nobel laureates. However, another set of researchers wanted to argue that chocolate consumption is not necessarily beneficial to society. First, they showed that this correlation here, that between chocolate consumption per year and the number of serial and rampage killers per capita in each country, or the log number of serial and rampage killers per capita. And so this correlation was 0.55, which is pretty good correlation as well. But and they also looked at the chocolate consumption per year and showed that it's correlated with the number of traffic fatalities. So they're arguing that perhaps the Nobel Prize winners are thinking about big ideas and not paying attention to traffic as they're crossing the street, thus resulting in more traffic fatalities. So the point of this is just to show that lots of different variables can be correlated. You can find correlations that are spurious, meaning meaningless, between lots of different variables, and so that's why correlation should not be taken as evidence for causality, because there's lots of ways you can get two variables to be correlated that have nothing to do with causality. So one more example, this is from the journal Nature, and this was published in 1988, and showing that, suggesting that the reduction in breeding storks is related or is causing the decreased birth rate in West Germany. So obviously this is a joke, but again, it's just a, researchers like to make these jokes. They're published in great journals, and so I thought I'd just share them with you, and hopefully it'll just help you remember why when someone gives evidence for causation by presenting you with correlational data, why you should always be suspect of that. And we'll talk a lot more about that later when we look at study design. Okay, so that's all for correlation.